So, Paul, hello, Paul. How you doing?
Hi Keith, how are you? You hear me okay?
Brilliant, got you perfect there. I've got a really nice picture of you there and a beautiful site that's brand newly built. Looks lovely. So, do you want to give us a bit of a background on yourself and your engineering?
Sure, yep, no problem. So mechanical engineer. I started out as a machinery designer for quite a few years. So to design machines from scratch, and then kind of gradually moved into condition monitoring with vibration analysis. Spent a bit of time in Australia before I came back to Ireland about 5 years ago and moved into the biologics, which is pharmaceutical, but it's where we're actually growing cells for immunotherapies for cancer patients. So my previous plant, I actually had Stuart come over to demonstrate the MA camera because it had just come out, I think, about a year beforehand, and it was actually an easy sell because he caught a pump where it was just as simple as a loose bolt, and so the video came up. I showed it to my manager, and he'd never seen it before. He'd never seen the before and the after, and he just stood there kind of shaking his head. And his question to me was, "How quickly can you get this?" So, that was the beginning of it. And within a few weeks, we had the MA camera on site.
Yeah, I remember that very early on. You're an early adopter, weren't you? So, can you just give us we had a bit of background there on Phil's site, and it's very different at yours, and it's you've had two sites where you've used this technology, and you've actually had that brand new greenfield site, and you've been able to build a CM program from scratch, haven't you? And you've had a good budget to buy whatever you want. I mean, you've shown some great tools. You've got X-ray machines and all sorts of cool stuff. So, give us a bit of background. What's the culture like for maintenance there at those places?
Okay, so yeah, like you said, it's a greenfield site. There is a big budget there, but there's quite a big emphasis on having a return on investment. They definitely don't just buy something because it looks nice. So there's a strong emphasis on being lean, strong emphasis on being digital, and strong emphasis on condition monitoring technologies. So we basically have all the tools, most of the tools anyway, that you could want. And for the vibration program itself, I guess you could say we have a three pillar approach to it. So one pillar would be our IoT vibration sensors. One pillar would be a standard data collector, which is not used for a walk around program, but is more used for troubleshooting any kind of high frequency events that we have. And then we have the MA camera as well, which is for our low frequency events. So the analogy we sometimes give to it is that we are kind of like floating like a butterfly and stinging like a bee. So now it might sound a bit dramatic, but the way it kind of works is that our IoT sensors are always there in the background, and they're monitoring our critical equipment and any of the stuff that we would normally have on a walk around program. And then when it flags up that something is wrong, if there's a low frequency event and we decide, now we'd like to put the MA camera on it, well, that's when we take it out and we sting like a bee. So we take the MA camera out and we have like an intense focus on one asset just for that period of time until we have it fixed. And then when we have it fixed, then it basically goes back into the cabinet, and then we go back to floating like a butterfly. So it's yeah. I just thought that one up this morning. I thought it was a nice analogy for it, But what it means is that it frees people up, and it makes us lean. It means we don't have people doing preventative maintenance, and we don't have people doing walk-around programs. But when the time comes, we have the technology to intensely focus in on one piece of equipment. But we also have the people that are actually trained to use it as well.
So that just makes me think of earlier on, you've kind of mentioned it a little bit there as well, is if you've got a new plant that's been built and you're commissioning, so what you've just discussed there, you've got that overview, you can go to troubleshoot and so on. But when you're commissioning, you're starting from scratch. But why would it, like, you've got a £30,000 outlay for new technology to go and fault find a new equipment? How can you justify that with your managers? How does that work?
Quite easily. I guess, for us, for the biologics, the price of the product that you're actually making far outweighs the price of the asset, and it far outweighs the cost of the MA camera. So £30,000 might sound like a lot of money, but compared to a single batch in a biologics plant, it's not really much at all. So for us, the pressure on us is timelines, and the reason is, once we get approvals for certain therapies, we have to get that drug made, and we have to get it to market as quick as we can. Time is literally money. So although the quality of the installation might be very high, there is also pressure on deadlines. So for us, a verification that an installation is good, is worth its weight in gold, because if something does go wrong a little bit further down the line and you have downtime, that downtime costs a huge amount of money. So it's the cost of the camera itself is actually small compared to what the implications could be if you had a failure.
Yeah, so right in that commissioning phase, you're looking for those issues, and then so you're nailing them before they become later on.
That's right. That's exactly it. Yeah.
That's really good. So we've actually got one of your case studies as well. There's a bit more slides on it as well. So do you want to just talk us through these slides, what you've experienced here?
Yeah, sure. So this was in a previous role. So this was a cooling tower pump. So normally for us, when you're on the utility side, there's lots of redundancy. So it's not as critical as when you're on the process side. But for us, this one came to effect because, like you can see, the top one there, the footing on the on this pipe support had basically disintegrated. It's fallen to bits. Yeah. So what happened was, for this is a good example of being on site with the camera and having the training to actually do something about it. I would have got the email, I think, about 9 a.m. and by 9:30 a.m. I would have been over there with the camera, and by about 12 I would have had the videos made, and this little thing emailed back to the people themselves to show where the actual issue was. And then by 3 o'clock I would have had that little drawing done of where I thought the best support would be for that, and then you're done and dusted within a day. Because to me, this would be a small issue. It's not a huge project, and you can't devote that much time to it. But if you have the tools and you know how to use them, you can knock these things out, and then you can go back to the rest of your job, because there's always lots of things to do. So for this one, it was kind of an example of how you're not just using this for rotating machinery, you're also using it for pipe work and also for structural supports. And it's an example of how easy it is to use. Once you give these videos to people, there's no debating it as to where your issue is. You can see it. It doesn't lie. So that's the beauty of it for me. So that pump, that issue, that pump there, there's actually two issues in one. So I think the first issue was the structural support issue.
Yeah.
And then they went away and they fixed that. And then, about 5 weeks later, they came back and they said, look, that pump is vibrating something terrible. I'm not sure if that pipe support thing worked. So the second video you showed there was actually, we looked at it with the handheld data collector. There was a huge rise in the 1X, which to me normally means you've either got a balance issue or you might have some kind of flexibility issue. But if you've got a balance issue in a pump and you want to check the impeller, it's a huge big deal to bring down the pump and to drain down and open up the pipework and everything like that. So the MRA camera again was used pretty quickly within about 2 hours just to look at all the pipework, look at the plinth, look at the base plate, just to make sure there's nothing loose, there's no cracks or anything like that, and there's nothing else contributing to what that actual rise in vibration could be before we got the guys to open up the pump work. And so that again is worth its weight in gold, because to do that you've got all your permits, you've got multiple people involved, and at the end of it, the plinth and everything was actually fine. So when they opened up the pump work, they actually found that the strainer had disintegrated and was lodged in the pump itself. So it was a good find for me.
Brilliant. That's really good. Thank you very much for that, Paul. It's really informative.
Okay, no problem. Thank you, Keith.